Alright folks, today we're going to be talking about Lewis structures and just going through a bunch of different Lewis structures. You need a periodic table, obviously. I'm not going to linger on these. I'm just going to do it quickly, so you need to make sure that you have a periodic table so you can do valence electrons. Alright, each hydrogen has one electron, so that means there are 2 electrons there, and oxygen has 6, so that's a total of 8 electrons. So I take oxygen and I bond it to hydrogen for 1 and hydrogen for another. That's a total of 4. That's a total of 6. That's a total of 8. Remember, hydrogen only gets 2 electrons, so that's my total of 8 electrons, so I am done. Alright, Lewis structure for chlorine. Each of the chlorines has 7. There are 2 of them, that's 14. So chlorine to chlorine, that's 2, 4, 6, 8, 10, 12, 14. That's my 14. Everybody has 8 electrons. We're good to go. HCN. Carbon has 4, nitrogen has 5, hydrogen has 1. That's a total of 10. So there's carbon. We go to hydrogen on one side, we go to nitrogen on the other. That's 2, 4, 6, 8, 10. Now the problem is nitrogen's got 8, that's great. Hydrogen has 2, that's wonderful. Carbon only has 4, so that's a problem. So we get rid of those and make that into a double bond, and we get rid of those, make that into a triple bond. Carbon now has 8, nitrogen has 8, hydrogen has 2. All is right with the world. Okay, so that's HCN. How about H2? Well, each of the hydrogens has 1, so that's a total of 2. That's real simple. There we go. We're done. Right, nitrogen has 5, chlorine has 7, there are 3 of them, that's 21. 21 plus 5 is 26. So we take nitrogen and we go out to 3 chlorines. That's 2, that's 4, that's 6, that's 8, 10, 12, 14, 16, 18, 20, 22, 24. I have 2 more. They go on the central atom. That's 26. Everybody has 8 electrons. Again, we are good to go. N2. Nitrogen has 5. That means we have 10 electrons. There's 2 of them. There's 4 of them. There's 6 of them. There's 8 of them. There's 10 of them. Okay, well, each nitrogen only has 6, so we're going to get rid of those 2 and make a double bond, and we're going to get rid of those 2. We're going to make a triple bond. We now have both nitrogens both have 8, so that is N2. How about pH 3? Well, phosphorus is directly under nitrogen, so it has 5. Each of the hydrogens has 1. That's a total of 8. So there's hydrogen for 2, hydrogen for 4, hydrogen for 6. Each of the hydrogens only takes 2, so my extra pair goes up here with the phosphorus for 8. So phosphorus has 8, everybody else has 2, so we're good. Alright, CHCl3. Well, let's see. HCl, Cl, Cl. Let's see, each of the Cl's has 7, so that's 21. There's 1 there, there's 4 there, so that's a total of 26. Alright, well, let's see, I've done 4 so far. 6, 8, 10, 12, 14, 16, 18, 20, I did something wrong. There are 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. The chlorines all have 8 rather. The carbon has 8, the hydrogen has 2. We are done. How about NF3? Nitrogen has 5. Fluorine has 7, so that's 21. That's a total of 26. So we have nitrogen bonded to fluorine. Bonded to fluorine, bonded to fluorine, bonded to fluorine. That's 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Everybody has 8. We are good to go. HBr, bromine is a halogen, so it has 7. Hydrogen has 1. That's a total of 8. So we have H over here, we have Br over here. Remember, hydrogen only takes 2. We need 8 electrons. There are 8 electrons around bromine. Again, we are done. Oxygen. Oxygen has 6. There are 2 of them, so that's a total of 12. So oxygen bonds to oxygen. That's 2. That's 4. That's 6. That's 8. That's 10. That's 12. Oops, I'm done, but I only have 6 over here, so I have to get rid of those and make a double bond. So oxygen each has 8. Both oxygens have 8, and we are done. All right, we have to be a little bit more careful with this. Carbon has 4. Nitrogen has 5. We also have an additional one because of the -1 charge. That gives us a total of 10. So we take carbon, we bond to nitrogen, and nitrogen has 2, 4, 6. Plus this one is 8. We put some over there for 10, and carbon is short. So carbon, we need to get rid of those, and we need to put a bond there. We need to get rid of those and put a bond there. So carbon now has 8. Nitrogen now has 8. Everybody's happy. And we have to remember, since this has a -1 charge, to put a -1 out there. How about NO with a -1 charge? Well, nitrogen has 5. Oxygen has 6. We have one additional one. That gives us 12. We have nitrogen bonded to oxygen. We have nitrogen's going to be our quote-unquote central atom. So we now have 8. We still have to have 12. 8, 10, 12. And nitrogen appears to be short. So we'll take one from oxygen, and we have that. So now oxygen has 8. Nitrogen has 8. This thing has a -1 charge. Everybody's happy. We're good to go. All right, CO2. Carbon has 4. Each of the oxygens has 6. That's a total of 12 for a total of 16. There's carbon, oxygen, 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 oxygen. Let's see, that's 2, 4, 6, 8, 10, 12. I need to have 16, so I put a couple more out here. So there's 16, and my oxygens are happy. My carbon is not, because it only has 4. So I have to get rid of one of those, and I have to get rid of one of those, so that I end up with double bonds between the oxygen and the carbon. Okay. All right. Lewis dot structure for NH4 with a positive charge. Well, nitrogen has 5. Each of the hydrogens has 1, so that's 4, but I have to subtract 1 because I have a positive charge. So I end up with only 8 electrons for NH4. So here's N, and here's H, and there's H, and there's H, and there's H, and that's good because that's 8 electrons right there, so I'm done. Okay, oops, I had to put a positive charge. I have to remember, put my square brackets, and to put a +1 charge outside. All right, that's it. If you have questions, see me in class, and have a great day. Bye.